This might be SpaceX's most crucial moment yet. After 9 spectacularly explosive flights and a pad-side detonation in June, the company is gearing up for Starship's 10th test, a rocket that Elon Musk swears will one day ferry pioneers to Mars and beyond. But here's where it gets controversial. These dazzling stainless steel rockets haven't yet nailed all their mission goals, and critics are growing louder. And this is the part most people miss. Experts at top institutions now wonder if Starship's very design could be its undoing. As the countdown ticks towards Sunday's 7:30 p.m. Eastern launch from South Texas, SpaceX remains determined to achieve 2 milestones it hasn't mastered at the same time: a flawless liftoff and a flawless landing. Starship, paired with its Super Heavy booster, is engineered to be fully reusable. Imagine if every commercial airliner exploded on landing before it could take off again. In theory, this reusability could cut costs and open deep space travel to hundreds of people at once. During a May briefing, Musk framed this project as more than a series of rocket tests. It's a race to safeguard humanity. He argued that building a self-sustaining city on Mars is not just grand ambition, but a necessity. And he measures progress by how quickly Starbase can churn out rapidly reusable, reliable rockets. Not everyone shares his optimism. Olivier Dweck, a respected MIT professor of astronautics and engineering systems, is vocal about his doubts, especially about the Starship upper stage. He praises the Super Heavy booster for its relative success, but warns that every fix on the spaceship seems to spawn new glitches in a never-ending game of engineering whack-a-mole. Convergence, he explains, is the idea that each test should resolve past issues without creating fresh ones. In Starship's case, he says, one patch leads to an entirely new crack. The recent history reads like a film of near misses and fiery finales. In mid-June, a static engine test blew up on the pad when a pressurized nitrogen tank, vital for the crew cabin's breathing and cooling systems, failed catastrophically. Less than a month earlier, Flight 9 disintegrated mid-air due to mechanical failures that ripped the vehicle apart, and the booster tore itself to pieces upon splashdown from unexpected structural stresses. Flight 8 fell victim to a Raptor engine hardware malfunction that ignited fuel outside its intended path, raining debris across South Florida and halting airport operations. Flight 7 lost its spaceship to violent vibrations that ruptured propellant lines. After each incident, SpaceX has rolled out hardware upgrades and tweaked operational procedures, but Musk sees these crashes through the lens of agile engineering. Test fast, learn fast, improve fast. It's reminiscent of software developers pushing daily updates, except a failed rocket costs hundreds of millions and risks lives. That tension between rapid iteration and safety-critical demands is at the heart of the debate. For Flight 10, all eyes will be on the moment the Super Heavy booster steps away and Starship's upper stage Raptors ignite. If those engines light cleanly, the spacecraft coasts smoothly through space and re-enters without falling apart. It would be a landmark achievement. Yet if mid-flight flames or premature shutdowns plague this mission, will SpaceX press on with the same design for another 10 or 20 flights? Dweck bets they will. Musk, meanwhile, envisions a future where 2 or 3 new Starships roll off the assembly line every single day, heading to the Moon and Mars on a schedule more akin to city buses and spacecraft. We could be out there among the stars, making science fiction no longer fiction, he says. What do you think? Is this relentless cycle of explosive setbacks, followed by rapid fixes, the secret to building a multiplanetary civilization? Or is it a perilous gamble that could cost human lives? Do Elon Musk's Mars dreams justify such high-stakes engineering? Share your thoughts and let's debate in the comments.